Chapter 1, Section 1.2. We're going to talk about intercepts, symmetry, graphing key equations. So the topics for this lecture are finding intercepts algebraically, test equations for symmetry, and graph key equations. Hopefully you remember this from our last lecture where we talked about the x-intercepts and the y-intercepts. So remember from our picture, these would be our x-intercepts. And remember we talked about for the x-intercepts, your y value is always 0. Okay, that's going to be important now when we try to find the x and y intercepts. For the y-intercept, this guy, remember your x value is always 0. So let's find the x and y intercepts algebraically. Find the x-intercept or intercepts and the y-intercept or intercepts of y equals x squared minus 9 algebraically. Now one thing you're going to note is that, and in your homework and in the book, you're always going to have this s, meaning multiple. So we could have one intercept or we could have more than one. Okay? So let's look at our y-intercept. And the first thing we want to do is just write out our equation. Y equals x squared minus 9. Now remember, for the y-intercepts, the x value is 0. So what we're going to do is just simply put 0 in for our x. And we know that 0 squared is 0. So our y-intercept is negative 9, because 0 minus 9 is negative 9. So if we write that as an ordered pair, we would have 0, negative 9. Let's look at the x-intercept. Now this time, that's when y is 0. So I always like to start out by writing the equation again. Now we're going to put 0 in for y. Now we need to remember back to college algebra. When we want to solve this equation, we have to factor. But this one's kind of an easy one because it's the difference of squares. So it's x minus 3 times x plus 3. Now if you're not very good at factoring, definitely look into the help stuff in my math lab. And there's a video that will help you with this. But let's continue. Everything that has an x value, we're going to equal to 0. So x minus 3 equals 0. We're going to solve for x. So x equals 3. And then we have x plus 3 equals 0. We're going to solve again for x. So that's negative 3. So it turns out that we have two x-intercepts. 3, 0, because remember y is 0, and negative 3, 0. Now in your homework, it's going to ask you to write these as ordered pairs or it will be wrong. So that's very important. So let's graph these by hand. You should be really familiar with this, so this part will be a review. 0, negative 9, so 0, negative 9 is way down here. Then we have 3, 0, and negative 3, 0. And it's a parabola that, if I can make it work good here, looks like that. Now you notice anytime I draw a graph, I always have arrows at the end, because remember it goes on to infinity. And I personally am really picky about that, and there are other instructors that are also. So it's just a good habit to get into that. Next, let me show you how to do this on the calculator. Next, I want to show you how to do this on your calculator. And for some of you, this will be a review. Others of you, this will be brand new. So what I have here is the calculator. And on the right side, it's going to show you exactly the keys I'm pressing. So I thought that would be pretty cool. So I have x squared minus 9 in here. I'm going to click graph. So here's a picture of our graph, and of course it shows you exactly what I pressed. Let's find the x-intercepts first. So what you'll do is you'll press second and calc. Calc is in blue, so that's why I pressed the second key. We're going to go down to 0, And the first thing it says is left bound. What that means is you want your blinky, your cursor here, to be to the left side of this intercept. Hit enter. Now right bound, that means you want it to the right side of the intercept. Anywhere over here is great. Click enter. And then the guess, you just click enter again. So here's our first intercept. X is -3 and y is 0. And that's great because that's what we found first. Let's try the second one, because remember there's this x intercept here. So we're going to do the same thing. Second, calc, down to 0, and left bound. We're going to keep going over here. Now left bound means to the left of the x-intercept, so that would be here. We're going to hit enter. Right bound means to the right of the x-intercept, and hit enter. And enter for guess. And look at that! We must have done it right because we have x is 3, 0, and that is our two x-intercepts. Okay, let's find that y-intercept. I had to change my picture here so I could get the 0 key. So once again, we're going to go into second, calc. We're going to go to value this time. Now remember, for the y-intercept, the x value is 0. So we're going to enter 0, and then hit enter. And look at that. X is 0 and y is -9. So we must have done it right. It's pretty good. Our final topic in this lecture is going to be symmetry. We're going to talk about symmetry with respect to the x-axis, the y-axis, the origin, which remember is 0, 0, and then I'm going to show you how to test for symmetry using algebra. So first of all, let's talk about symmetry with respect to the x-axis. Here's an example. So here is our original, the one in pink here. And then this is the symmetry. It's as if you put a mirror there and you can see it. It's kind of cool. And the interesting thing about this, and some instructors make it really hard, but it's really, really easy. If this is your original, then x, -y, is the symmetry. So for instance, if I had 3, 5 for a point, the symmetry with respect to the x-axis would simply be 3, -5. And that's really all there is to that. So let's look at symmetry with respect to the y-axis. Once again, if I put a mirror on the y-axis, it would look the same on each side. If xy is my original point, my original ordered pair, then this time -xy would make it symmetric. So let's say I had 7, 9 as an ordered pair for my original. Then, to be symmetric with respect to the y-axis, it would just be -7, 9. Finally, let's look at a graph that's symmetric with respect to the origin. Now remember, the origin is 0, 0. Basically, it's going to follow this line y equals x. Okay? So if our original is xy, that's the original ordered pair, then it's just -x, -y. So let's say our original ordered pair is, I don't know, 3, 8. Then the ordered pair to be symmetric with respect to the origin would be -3, -8. So let's look at our first example. If a graph is symmetric with respect to the x-axis and the point -1, 3 is on the graph, then what point is also on the graph? So our original is -1, 3. Now remember, and I put our little note down here, basically the x stays the same, but the y changes. So what point is also on the graph? -1, -3. Because remember, it's only the y that changes. Let's look at this example. If a graph is symmetric with respect to the y-axis and the point -1, 3 is on the graph, then what point is also on the graph? Well, let's write our original out here, -1, 3. And I have our notes down here, and hopefully you're going to put this in your notes and put it in your notes for the test. So basically it's the x value that changes this time. So from a -1 it goes to a +1, and the y value stays the same. So what point is also on the graph? 1, 3. Let's look at our last example. If a graph is symmetric with respect to the origin, and the point -1, 3 is on the graph, then what point is also on the graph? So I put our little notes down here to help us. So the original is -1, 3. If it's symmetric with respect to the origin, then both ordered pairs are going to change. So the -1 turns into a +1, the 3 turns into a -3. So what point is also on the graph? 1, -3. So here are the rules for tests for symmetry. I would write these down, but I'm also going to show you how it works. Basically, for the x-axis, you just replace y with -y in the equation. If an equivalent equation results, the graph of the equation is symmetric with respect to the x-axis. The y-axis, you replace the x's, and the origin, you replace the x and the y's. So it's a lot of words, but let me show you how this works. Let's try this example. For the equation y = x squared, test for symmetry with respect to the x-axis. So let's write our equation out. Y = x squared. Now remember, all we're going to do is exchange this with a -y. So we're going to put -y in for y equals x squared. Now, what all that gobbledygook before said is basically if these two equations are exactly the same, then it's true. Then this equation or this graph would be symmetric with respect to the x-axis, but it's not true. So here's a picture of y = x squared from the calculator. Now we notice that if it was symmetric with respect to the x-axis, it actually would look like this. So this equation is actually symmetric with respect to the y-axis. Let's look at the next example. For the equation y = x⁻³, test for symmetry with respect to the y-axis. So once again, I like to start with the original. This time, we're going to substitute -x in for x, which gives us -x⁻³. Since these guys are not the same, it's not symmetric with respect to the y-axis. And you know what? It turns out not to be symmetric with the x-axis either. So let's see if it's symmetric with the origin. Now remember, with the origin, both of these change. So we'll have -y equals -x⁻³. So this gives us, make a little arrow here, -y equals -x⁻³. Interesting, if I divide by -1 on both sides, I end up with y equals x⁻³, which does look like my original. So y equals x⁻³ is symmetric with respect to the origin. So let's look at our calculator for a second. If I drew the line y equals x, it kind of looks like this. I'm not very good at it freehand, but it is symmetric with respect to the origin, because if you kind of flip this guy over like that, it looks exactly the same. I want to take just a couple more minutes here to talk about the graph of key equations. A lot of you probably know this already, so you can just skip through this part of the video, but let me review it for a second. We're going to look at y equals x squared, y equals x to the third, and y equals 1 over x. So first we're going to graph the equation, we're going to find any intercepts, and we're going to check for symmetry. And we're actually going to do that on the calculator. So I've already graphed y equals x squared, and here's what it looks like. To check for symmetry, let's look here for a second. I have negative 1, 1 and 1, 1. Remember, when the x values change, that tells me that it's symmetric with respect to the y-axis. So that's easy just looking right at the table. Let's review for a second how to find the x and y intercepts. Now we kind of know that the x and y intercepts are going to be the same. So let's go to second, calc, and let's just do value. When x is 0, that gives us our intercepts, and 0, 0 is the x and y intercept at the same time. Let's look at this one. We're going to graph the equation y equals x to the third, find any intercepts, and check for symmetry. So here's our calculator again, and I have graphed x to the third. This is what it looks like. Now let's look at our points. So we have negative 2, 8, and we have positive 2, 8. So both of these have changed signs. So that definitely tells us that this graph is symmetric with respect to the origin. Now if we look at it, it looks like we have the x and y intercepts are 0, 0, but let's just make sure. Value, we're going to put 0 for x, and it turns out the x and y intercepts are at the origin 0, 0. We're going to graph the equation y equals 1 over x, find any intercepts, and check for symmetry. So here's the calculator again, and as you see I've graphed y equals 1 over x. I have changed the window so we can see it a little better. Let's look at our table. We have negative 2, negative 1.5, negative 1, negative 1, and you'll notice negative 2, negative 5 has 0.5 has now changed to 2.5. Negative 1 is changed to 1, 1. So that tells us that this graph is symmetric with respect to the origin. Now there's a couple interesting things. First of all, at 0 we have an error. That means that this line never touches the y-axis. And it also turns out that this line, this graph, never touches the x-axis. So there is not an x or y intercept. Okay, you're ready to start the assignment, 1.2 homework. Make sure you always check the calendar for due dates, and any homework that is not completed on time or completed after the due date will be deducted 10%. So you want to make sure that you have your homework done on time.